Hi, it is JIT UA Courses, and welcome to lesson number 17 of the .NET Developer series, in which we will cover the most relevant topics to becoming a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will learn about web servers, HTTP, application domain, and application pools. If this sounds interesting to you, don't hesitate and hit the like button. How the internet works. The internet can seem like magic. Web pages, music, and videos are taken as if from nowhere. But all this is the result of the work of a large system. It is also necessary to understand that the internet is not one big program, but the result of the interaction of millions of network participants and their programs that work together in this network. Physically, the internet is many computers that are connected by a cable or using wireless data transmission. We can create our local network if we connect only our computers to it and close external access from other networks. The internet is many small local networks that are connected using routers and gateways one with another into a large global network. For example, the internet in China is not like ours, because it is disconnected from some networks and from the resources they have. There is no access to Google, YouTube, or Facebook, but there is only their local censored versions. So we conclude that there are users of resources and providers of resources on the internet, and of course, the same network participant can simultaneously use resources and provide his resources. The entire internet is built on the exchange of messages between participants. Users in these messages request a certain resource, and the owners of the resource respond to this message with their message containing this resource. Users are called clients. The owners of the resource are called the server or web server. The language, protocol, of messages in which they communicate client with the server is called HTTP. HTTP, a data transfer protocol used in computer networks. The exchange of messages follows the usual request-response scheme. HTTP uses global URIs to identify resources. URI is a unique link to exactly the resource you are interested in, for example, a web page or a file that the server provides to its users. Unlike many other protocols, HTTP does not store its state. When a client sends a request to the server, either receives what is asking or an error if something goes wrong. However, we do not know what happens between these request/response pairs, whether this resource has already been requested, whether there was an error, or whether it is the same client, etc. Components using HTTP can independently save information about the state related to the latest requests and responses. The server can store the IP addresses and request headers of recent clients. However, according to the protocol, the client and server do not need to be aware of previous requests and responses. The protocol does not provide internal state maintenance, and it does not impose such requirements on the client and server. Each request has a title that explains what it is for and to whom it is addressed. Where the method is one of the request types supported by HTTP protocol. Options. Returns the HTTP methods supported by the server. This method can serve to identify opportunities for web server. Get. Requests the content of the specified resource. The requested resource can accept parameters, for example, a search engine can accept a search string as a parameter. They are passed in the URI string. According to the HTTP standard. GET requests are considered idempotent. Multiple repetitions of the same GET request should lead to the same results, provided that the resource itself has not changed during the time between requests. This allows you to cache, temporarily store, responses to GET requests. If the name of the resource is not specified, the URI contains only the scheme and the domain name, then the web server returns the directory index web server, i.e. default pages. Head. Similar to the GET method, except that the server response has no body. This is useful for extracting the meta information specified in the response headers without forwarding the entire content. In particular, the client or proxy, by checking the last modified header, can thus make sure that the page on the server has not changed since the previous request. Post passes user-defined data, for example, from an HTML form to the specified resource. For example, in blogs, visitors can usually enter their comments on posts in an HTML form, after which they are sent to the server via the post method, and it places them on the page. At the same time, the transferred data, in the example with blogs, the text of the comment, is included in the request body. Unlike the get method, the post method is not considered idempotent, meaning that repeating the same post requests multiple times may return different results. For example, each time a comment is sent, one copy of that comment will appear. Put downloads the specified resource to the server. Patch downloads a certain part of the resource to the server. Delete deletes the specified resource. Trace returns the received request so that the client can see what the intermediate servers add or change to the request. Connect for use with proxy servers that can dynamically switch to SSL tunnel mode. Get and post methods are mainly used. So server returns the status code with some description. Status codes. 1xx, informational, the request is accepted, continue the process. 2xx, success, the action was successfully transmitted, understood, and accepted. 3xx, redirection, the following actions must be successfully completed to implement the request. For XX, client error, the request contains syntax errors or cannot be executed. 5xx, server error, the server could not execute a properly formed request. The most common statuses. 200 OK, the request was completed successfully. 301 moved permanently, the resource has been moved. 403 forbidden, access to the requested resource is prohibited. 404 not found, the resource was not found. 503 service unavailable, the service is unavailable. HTTPS. HTTPS is the same protocol as HTTP, but the requests of which are encrypted and can be read only by the server and the client who has the encryption keys. Yes, HTTPS is HTTP, but almost all of its essential elements are encrypted. URL requests, including the path and name of the resource, page, request parameters, headers, and cookies, which often contain personally identifiable information about the user. Not encrypted, host, website, name or address and port, as they are used by the TCP/IP transport protocol to establish a connection. Encryption guarantees moderate protection against eavesdropping and man-in-the-middle attacks, provided that the settings are correct and the certificate is signed by an authorized certification authority. HTTPS is especially important in unsecured networks, such as public Wi-Fi hotspots, because anyone on the local networks can analyze the traffic and intercept or modify information that is not protected by HTTPS. This means that a hypothetical attacker could potentially steal a user's private data, gain access to an account, insert malicious code or software links into pages sent to the user in response to their requests, and more. To prepare the web server for accepting HTTPS transactions, the administrator must create a certificate with a public key for the web server, the key that the client will have for encryption. This certificate must be signed by a certificate authority, which certifies that the recipient of the certificate is exactly the person mentioned in the certificate, namely, that the site belongs to the company and represents it, and is not just a fake site. Thus, only this server will be able to decipher the content of messages to it, because the certificate also gives the server a private key that can decrypt the information encrypted by the client with the public key of the certificate. Web server. A web server is a server that accepts HTTP requests from clients, usually web browsers, and issues HTTP responses to them, usually along with an HTML page, image, file, media stream, or other data. A web server is one of the foundations of the World Wide Web. A web server is both the software that performs the functions of a web server and the computer on which this software works. Clients reach the web server by the URL address of the web page or other resources they need. Additional features of many web servers are keeping a server log of user access to resources, user authentication, support for dynamically generated pages, HTTPS support for secure client connections. Completely different devices can be used as clients to access web servers. A web browser is the most common method. Special software can independently contact web servers for updates or other information. A mobile phone can access web server resources using the WAP or HTTP protocol. Other smart devices or household appliances. It is necessary to understand that the web server is a special program that serves web requests to the computer. It can respond to the request itself, but in our case, we, as software developers, can use it so that the response to the request is not generated by the server itself, but by the computer, a computer program that will process such a request. And we can create such programs in the C# language. App domain. Application pools and application domains are two different concepts, but a good understanding of these concepts is essential to building secure web applications. Application pools contain one or more worker processes that share the same configuration and application boundaries. An application pool consists of a set of URLs served by a single worker process or a group of worker processes. Applications running in one application pool do not affect other applications running in other application pools. Application domain is a lightweight process that provides a logical and physical isolation boundary for your programs running in the CLR context. It is a lightweight process that has its own set of data, code, and configuration options. Application domains allow multiple applications to coexist in a single process. The default application domain is created and the CLR is initially loaded. If one application domain crashes, it does not affect the operation of the other application domain. An application domain with its own virtual address space is a logical barrier for code, security, reliability, and version control. It should be noted that application domains are created by runtime hosts. App pool is used for the operation of our program with the IIS server from Microsoft, which is mainly used for the operation of web applications written in .NET. This makes it possible not to terminate the server even if one of the requests to our web application receives an error, the whole process is not complete, and the next request can be processed successfully. The app domain is generally used for all applications that run in the CLR. And from allows you to run several applications in one process. Even if one app domain received an error, the others work because the process has not been completed. IIS, Kestrel. IIS, Internet Information Services, is a set of servers for several Internet services from Microsoft. IIS is distributed with Windows NT family of operating systems. The main component of IIS is a web server that allows you to host websites on the Internet. That is, IIS is a separate program in which, with the help of a graphical interface, you can create apps to serve your sites and link the web address that you chose to activate your web application written in C#. This is what the IIS interface looks like. On the left are sites created in IIS. On the right, actions with the selected site. And auxiliary services in the center. Kestrel is a lightweight open-source cross-platform web server for ASP.NET Core. He is on by default in ASP.NET Core. Kestrel is supported on all platforms and versions supported by .NET Core. In the program class, the configure webhost defaults method configures Kestrel as the web server for an ASP.NET Core application. Although Kestrel can serve an ASP.NET Core application on its own, Microsoft recommends using it with a reverse proxy such as Apache, IIS, or Nginx for better performance, security, and reliability. The main difference between IIS and Kestrel is that Kestrel is a cross-platform server. It runs on Linux, Windows, and Mac, while IIS is Windows-specific. Another major difference between the two is that Kestrel is completely open source, while IIS is closed source and developed and maintained only by Microsoft. IIS is an old but powerful piece of software. With Kestrel, Microsoft started with cross-platform compatibility and high performance as clear design goals. Because the Kestrel codebase started from scratch, it allowed developers to ignore legacy or compatibility issues and focus on speed and efficiency. However, Kestrel does not provide all the features of a full-fledged web server such as IIS, Nginx, or Apache. So we usually use it as an application server, with one of the above servers acting as a reverse proxy. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell so as not to miss the following videos in the series. Feel free to leave a comment and like this video. You are also welcome to leave any questions in the comments section. I will be happy to answer them. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.